Hey, everybody. Welcome to Project Geospatial as part of the Geospatial Frontier Virtual Technology Fair, hosted by Project Geospatial and partnered with the American Geographical Society. With us for this session is actually Ryan Lewis to talk and do a deeper dive into SpaceNet LLC. Ryan, I'm going to pass it off to you. You can tell a little bit about yourself if you want, and then we'll just dive into the conversation of what the organization is all about.
Well, Adam, thanks for the opportunity to present at this trade show. I've been following all of your presentations so far, and it's been great. It's also great just to be back with Project Geospatial. For those of you who may have listened in the past, we have highlighted several of our specific data science challenges, namely some of the results from SpaceNet 6, which we just concluded. So today's a really neat opportunity for us to not just talk about a specific challenge, but also the organization as a whole, how we got to where we are today, and more importantly, where we're looking to go. So for those of you who haven't met me or listened to some of the previous episodes, I'm Ryan Lewis. I work at Incremental Cosmic Works, which is an applied research lab. And one of our core projects that we do is manage SpaceNet LLC, which I serve as the GM for. And with that, I'd like to get into the slides, unless, Adam, there's anything else.
Oh, stand by. Let me switch over to those and go for it.
Outstanding. And so at the highest level, SpaceNet is a nonprofit LLC that is dedicated to accelerating open source work around geospatial applications, specifically for foundational mapping. Right, and this really started as an effort for us simply because we found that when Cosmic first got underway, that there wasn't a robust ecosystem for geospatial analyses, particularly leveraging new deep learning techniques. And one of the things that we have focused on over the years is building out that ecosystem in concert with a variety of other partners that are also working in this space. And so as you'll see, a variety of logos on this chart, we have systematically added new partners over the years. And so when we first got started, SpaceNet was an informal effort that was really a collaboration between CosmicWorks, my team, and at that time, Digital Globe, now Maxar. Over the years, we have systematically added new partners who have helped us make data more available, expand the amount of research that we do through either blogs or published papers, as well as making more data sets or more unique or novel data sets available through challenges. One of the big questions that we get a lot, and Adam, this is something I regret not putting up in previous presentations, is how we got here. It's a question that I've often skip over, but I think it's kind of increasingly important as we continue to build on top of previous efforts. And so to go back to the very beginning, as I mentioned, SpaceNet started as really an informal effort in August of 2016. And it was really just an effort to see if we could put out a labeled data set and build at least some interest among, at that time, the early computer vision community around geospatial applications. As all of you know, particularly for those of you who have followed Project Geospatial before or are deeply ingrained in the geospatial community, analyzing geospatial data sets is tricky by the very nature of some of the unique qualities that particularly satellite data, provide. And so sometimes those hurdles can provide challenges. Going back also to 2016, it wasn't just a software or a model tuning problem, but it was also just a data availability problem in the sense that there weren't a lot of quality labeled data sets that were also licensed in a permissive way for either researchers or corporate groups to do work and then publish upon that work. And so our thought was, let's go out, put some data, structure it around a challenge, and see what type of response that we get. And so after starting the initiative and thinking about different types of data science challenges that we could pursue, we launched our first challenge, SpaceNet 1, in November of 2016. And although we got a lot of interest early on, we realized there was a lot more that we could do. And so, building on a lot of the lessons learned from SpaceNet 1, we expanded into very quickly SpaceNet 2 and then SpaceNet 3. And the goal there was to expand not just the type of challenges that we're posing to end users, but also increasing the diversity of data that we were presenting to end users as well as the broader research community. And I think a major milestone for us was really when we saw the data set, which is hosted on AWS's Open Data Program, which I highly recommend any of you check out, both for just looking at SpaceNet data as well as the vast different libraries that that program provides. It was a big deal when we saw that we had over 100 million unique hits on that S3 bucket. That really told us for the first time that we saw momentum, not just in the challenges, but in going back to that word ecosystem, in the broader sort of community that was building around this sort of body of work. That really told us that we wanted to take our efforts one step further and move from a sort of an informal initiative with different corporations providing either resources or contributions and move it to a more structured organization. And so in October of 2018, we launched SpaceNet as a nonprofit organization that's managed by Incremental Cosmic Works. And the two co-chairs are my organization and then Maxar. Once we had that organization in place, we quickly then launched SpaceNet 4, and then in the following year, SpaceNet 5. And what's been really compelling from that time, from essentially launching the LLC to those challenges, is in the span of a little over a year, about a year and 2 months, we saw the hit rate growth exponentially. And so in around November of 2019, we saw about 500 million unique hits on that S3 bucket. And that's just been really exciting to see not just a growth in this effort, but more importantly, the growth in interest in geospatial problems among not just computer vision researchers, but just really more broadly, just AI researchers. And that was really one of our core goals when we got started. And so we felt that was something we were celebrating. Fast forward to today, we just concluded our 6th challenge, which we'll talk a little bit more about in a little bit. And that was unique in the sense that it was our first multimodal challenge. So not just including electro-optical imagery, but also a synthetic aperture radar. And for the first time, one of our challenges will be featured at a CVBR workshop, specifically the IEEE GRSS Earth Vision workshop. So it's been an exciting progression over the span of, it's hard to believe, almost 4 years between challenges, organizational structure, partnership growth, and I'm really excited to see where things can go next. And we'll talk about some ideas that we have for future challenges. You know, if there's one thing to kind of remember from this discussion, it's think about what we do in sort of 4 pillars. And this is something that really hasn't changed over the course of 4 years. Maybe it's been modified a little bit, but it's stayed pretty much the same. And those 4 pillars are labeled data sets, public data science challenges, open source algorithms, and then the evaluation of those algorithms. All of this work rolls up into supporting that broader ecosystem. So whether you are a practitioner or a researcher or a student that has been focused on geospatial since the beginning, or you're someone who is more interested in just general advanced analytics but not super familiar with geo, regardless of your experience or expertise, you can hopefully plug into the SpaceNet ecosystem and broader groups and really be able to get off and running pretty quick with data set, code, some tutorials, and pre-trained models, as well as some detailed evaluation about where those models could be good and not so good. From a data set side, we'll talk a little bit more into the details about what's in the data set, but to date we have 11 cities and almost 1 million building footprints labels across those 11 cities, and about 20,000 kilometers of road labels. All of these labels are manually annotated and curated before they are pushed up into our S3 bucket and used in a data science challenge. We work to release a new data set with each challenge. And so essentially what that means is we have about 2 data set updates a year. To date, we've hosted 6 data science challenges. Each challenge has had about $50,000 in total prize money, which equals to date, we'll be paying out our SpaceNet 6 prizes next month. So that will bring us to a total of $300,000 over the course of the 6 challenges. And that has brought in about 3,000 total technical submissions across those challenges. To date, we've open sourced 23 algorithms. All these can be found in our GitHub repository. And these models are built really across 2 different applications, building footprint detection and then road network detection and routing. And last but not least, and I think it is certainly something that we as a SpaceNet community receive a ton of feedback on long after a challenge has expired, is the evaluation of models. So once a challenge concludes, it's not just a matter of figuring out which are the winners and allotting them the prize money. It's also an effort to detail what were the strengths and weaknesses of those models. And this can run across a wide range of questions, from looking at how robust those models are, how transferable they are, or generalizable, and how computationally intensive they are. I.e., are these things that require massive compute even for inferencing, or are this something that can run fairly lightweight and perhaps even on a laptop in certain circumstances? The whole point of doing these types of evaluations is that allows any type of end user to understand what the strengths and weaknesses are when they're thinking about either expanding upon that work or leveraging it for some other project that they're leading. And a majority of these evaluations are really published in 2 areas, on our blog, which I'll provide links to at the end, and in published papers that we put out both on archive and whatever the specific journal may be. And once again, I'll provide links to that at the end of this presentation. It's a small topic, but an important one when we talk about how usage rate has increased over time. And specifically to focus on the availability aspect here on the slide, I would argue that one of the big differentiators for us from when we got started in thinking about a data set to when we launched SpaceNet 1 and then going into 2 was assigning the right licensing for the data set, both the imagery and the labels that are code registered on that imagery. So to date, all labels or all data that we release through the different SpaceNet challenges have a Creative Commons 4.0 share-alike license. So this allows commercial companies, academic groups, or other nonprofits to leverage those data for however they see fit. And it was really once we assigned that label, or once we assigned that license to the data set, we saw really strong growth. And I think as we look out in terms of how we add other data sets or other challenges, making sure that we maintain that licensing structure to make the data set and the findings from those data as accessible as possible is critical. I think the other important point is that as our work has matured over the years, we've had increasing focus on accessibility and interoperability. There's a lot of great challenges that are starting to either take shape or have been posted in the last couple of years that are focused around geospatial work. I know just on the SpaceNet site alone, we've also hosted some of the data from previous IARPA challenges, namely functional map of the world. I think one of the core things that we've learned is that making sure that these data are accessible and easy to access long after an individual challenge concludes, so people can continue to build upon that body of work. I think the other core piece getting to interoperability is that making sure that the data are in some of the best emerging standards to make it easy to find and easy to exploit for analysis. And so as a result, we have focused on building out the data set utilizing the cloud optimized GeoTIFF or COG format, as well as updating our data catalogs so they are following the STAC or Spatiotemporal Asset Catalog guidelines. Really getting into the data set, I mentioned that we have 4 geographic or 11 geographic domains thus far, and really the motivation there has been to systematically increase the diversity in scenes in terms of urban areas as well as geographic areas, and most recently as well as seasonality. So having not just winter or summer scenes, but also having some winter or fall scenes. All of these changes are important when one is looking at the impact of change of scene, or more importantly, when they're thinking about how to build on a model that can be generalizable. I think one of the things that's really interesting, if you look back to some of our previous challenges, we've really tried to move with each challenge to forcing, or not forcing, but really encouraging participants to build more generalized models as opposed to city-specific models. The other piece that I've already alluded to is that with the launch of SpaceNet 6, we've also started to move into multimodal data sets, which is really exciting. And it's something that I hope we can keep up with in the coming challenges. I mentioned this before, but our data set it comprises of obviously the raw satellite imagery, both the raw and pre and post processed, but also with labels. Our focus since the beginning has been foundational mapping. This takes the form of 2 different types of labels, building footprints and road networks. And this is something that we want to stick with over the course of future challenges. I think an important point here, and there's not a slide for it, but it's worth calling out, is that how we evaluate essentially scores with these different types of labels. And you can find this content on our website, both through in our GitHub repos as well as our blogs. But we have assigned specific evaluation metrics for both buildings, and then with roads, we actually created our own evaluation metrics, specifically average path-like similarity, or APPLES. This was something that was created by one of my colleagues, Adam Van Eaton, to encourage not just the measurement of how well a participant can extract a pixelized road network, but also how they can, how we could score the ability to route on that road network. And I think that's something that has been really interesting in terms of building out results from the road-specific challenges. So as I mentioned, we've done 6 challenges to date, and one of the things you've heard, I think at least at a high level, in some of the previous times we've either been on Project Geospatial podcast or other presentations, is that we usually say, we've focused on taking an incremental approach to adding complexity in these challenges. And once again, while it may seem kind of like an obvious pick, I think it's something important to key in on, because particularly with all the excitement in the geospatial market today, with the combination of adding new data sets and then merging with some of these advanced analytic techniques, it's really tempting to run off and try to take on some of the most challenging problems. And while there's a lot of great work to be done there, I think through some of these challenges, we've been able to systematically baseline where the current state of the art is in open source models, and then incrementally add the next level of complexity. To provide an example of this, when we first got started back in 2016, the team and I were really interested in thinking about how we could do a multimodal effort. But at the time, we weren't certain on how to even go about getting the data set. We had really no understanding of where the current models were at. And we really didn't know if even just having one city with just detecting buildings really didn't have a good sense of where current participants would be in a challenge. And what was really interesting from that first effort was that we found that while there was some really good work being done, is at least in November 2016, it was still a really hard problem. And so that really level set us to say, you know what, we need to think more long-term about how we can add complexity over time without having competitions that essentially have really poor performance. And I think this has been something that I know I'm personally proud of, and I've been really excited to see how all the participants who have participated in our challenges over the years have increasingly upped their performance as we have increased complexity. So I'm really proud of the work they've done and some of the models we've been able to open source. I think looking ahead and looking at this guidance, I think there's a couple of key themes that jump out of this right away. One is that we want to continue to increase that complexity, but also we want to continue to add that geographic diversity in the data sets, as well as continue to add novel features in those data sets. And I'll talk a little bit about that. Yeah, as I mentioned, we just closed SpaceNet 6. This is an effort that is being led right now by one of my colleagues, Jake Schurmeyer, and another one of my colleagues, Daniel Hogan, helped write the algorithmic baseline. But we launched the challenge on March 16th, and we just concluded it on May 1st. We'll be announcing the winners, as well as posting our first evaluation of some of the models at the CVPR workshop, or specifically Earth Vision, which is on June 14th. No good presentation would be complete without at least having a little bit of a teaser. And I think one of the things we're working hard on right now as we go through the test and evaluation period for SpaceNet 6 is that we are laying the final groundwork for the structure for SpaceNet 7. And so at the workshop, in addition to announcing the winners from 6, we'll be giving our first teaser about what's coming for SpaceNet 7. We're looking to launch that in the late summer, early fall. And I think one of the things that we're particularly excited about is that just like some of our previous challenges, specifically 6, most recently, we'll be launching yet another novel data set that I think will really be interesting to both researchers and practitioners in the geospatial domain. So I'm really excited to be putting that information out there as we get the finishing touches. Below the link at the bottom here is also linked to the Earth Vision workshop where we'll be releasing some of that information. And it's always important to kind of step back and say, are we still on track, with some of our goals? And as I mentioned when I was going through the timeline piece, we said it was a major win for us when we saw that we crossed a certain level of unique hits on our data set S3 bucket. And I think one of the things that we continuously kind of check on is, are we still having that engagement? Is it still interesting to both researchers and practitioners? And I think one of the things we're proud of is that the answer is yes. And so, but the ask would be is that as we continue to release either data sets or code, let us know what you think. Reach out if you have different ideas or particular challenges that you've been thinking about that maybe you'd like to have us take on. Yeah, I'll conclude today's presentation before we get to questions and answers just with a couple of links here. As you might guess, our goal through this effort is to make as much of this work as possible as easy to find. The best sites for this are through spacenet.ai. That's where you can find our data sets, the challenge constructs. You can also find information or direct links to our GitHub repository. I mentioned our blog post and some of the research papers we put up on archive. You can find that easily through the cosmicworks.org site. You'll just see the blog tab. And then under the resources page, you can find links to all the different papers that we have published around different SpaceNet topics. With that, Adam, I'll turn it back over to you. And if we want to dive into a couple of questions, that would be great. Thanks.
Yep, let me switch frames over here for a second.
Cool.
Stand by. Okay, so I do have a couple that came in. So the first one, let's kind of go backwards here for a second based off of the last slide you just did. Can you give us some insight for the different challenge suggestions you'd be willing to hear out from the listeners?
Yeah, absolutely. I think one of the core things that we're always interested in is any effort that can leverage some of the existing label structures that we provide. So the building footprints and roads piece. And so specifically what we've been thinking a lot about as a team is what are other data sets that can support or that are complementary to those types of labels. I think in the near term, we want to focus still on foundational mapping applications. So if there are other aspects of foundational mapping beyond those two different label types, I think that's something that we'd be very interested in hearing about.
Awesome. Thanks. And I definitely want to put that type of plug within the show notes for that. That's an awesome initiative to take those types of suggestions. I think you're going to get a lot of feedback for that one. Next one is, can you go into the interoperability topic just a little more? Is there research you've done with a wider community on how you would like that to interact with data to gauge what types of data you need to output to make available, if that makes sense?
Yeah, I think that's a great question. And it's one that is, I would say, still very much a work in progress across the geospatial community. I'd say we have been primarily participants and supporters of some of the work that is coming out of the Radiant Earth Foundation, specifically some of the work that's been led by Chris Holmes and his team around both mainly stack and then to a lesser extent, but still emerging, is some of the ideas around the analysis ready data or ARD initiatives. And for us, when we saw some of the progress that was being done in stack, it seemed like a no-brainer for us in the sense that it would make a lot of our holdings in terms of the data sets that we're putting out in X3 much more easy to query and search for. And that was a pain point that was very much in the front of our minds at the time when I first started looking at some of the stack work, or specifically we got involved around the third sprint, namely because we were getting a lot of feedback saying, hey, there's a ton of folders, not as easy for us to kind of query around and see everything or find everything that we want very quickly. And so I think that has been a big effort for us in terms of hopefully making our file structure easy. I would say that not all, we're not stack compliant yet across the entire, or across all the data set yet. I think that's a goal for us by the end of the year. So I would say it is very much a work in progress. On the second piece, I would say there was, and this touches a little bit more on some of the ARD work that's been unfolding, but I'd say that's still a little bit of a work in progress in terms of organizations coalescing around what does it really mean to have analysis-ready data from a standards perspective. I think some of this came out. If you look at, most recently, if you look at the OGC workshop last week focusing on analysis and visualization of geospatial data, I think there's a great conversation around this topic. I think there is a fair amount of work to be done still on identifying those common denominators across all different groups when they say that this is what it means to have my data be analysis ready. I think that's a key step before we can get into interoperability across a wide variety of data sets, which, as you know, probably just the questioner knows, it takes a lot of pre-processing work to standardize a data set for analysis if you're pulling in different sources. I think the ultimate goal would be to lower that level of effort so you can get into the reason you're doing the work, which is getting into the advanced analytics piece much more quickly.
No, I hear you. And for me, coming from a military analyst standpoint, I think, what you touched on with getting OGC standards in place, and this could be a completely separate philosophical discussion on that. But what, because in my point of view, to me, making standards isn't just about making standard to have everybody fit into that standard, but also I think the reverse is true in understanding what standards the users commit to already from that level, the analyst workers, even the military workers, the folks who adopt their own methodologies that work, that may not necessarily get exposed to a higher level as much. And I think there's a little bit of a disconnect in saying, hey, it doesn't have to, how do you create some overlap or some crossover from some of the advanced analytics to fitting in formats that work on day-to-day workflows so that they can play around with the data, use it, and figure out what works in the day-to-day analysis, And I hate to say it, but you still got those traditional formats like shapefiles, KMLs, CSVs out there, but no one talks about fitting some of these bigger advanced data sets into those more simplistic formats that have been out for years. But the sad part is those are still really the ground, even below the OGC level. Those are still the connection between everything still,
Yes, particularly with KML. And, I think, one of the things that's really interesting about where we're at as a community is that you really have, on the standards debate, you really have a confluence or a convergence of two different cultures. So you have very much your either classic GIS or geosciences researcher community, and then you have this sort of new, sort of more data science focused group. And the thing that's interesting to watch, I'm more obviously in the latter category. It's interesting to watch how people think about data sets and what they want out of them, and what they're interested in and what they're not interested in. And I think that's where you see right now some of the conflict is to say, I find these variable or metadata features critical, and we should have some structure on that. Or you say, hey, I just want to be able to upload these files quickly and analyze them. I don't care about some of these other features. I think that's where you're seeing not the conflict, but you're seeing a lot of the discussion. So certainly an exciting time for us to be, for all of us to kind of be working in this industry. And I think there's a lot of work to be done in terms of finding that middle ground between those two groups, and also identifying where you may want different standards for more rigorous science work as opposed to perhaps just an early analytic project. So a lot to be done there.
Awesome. Well, I think this is a good segue into the next question we got from the audience. So what are the current technical challenges you're still working to overcome as an organization?
Yeah, that's a good question. And there are a couple, and you can kind of intuit it. You can intuit some of them from the timeline that I laid out, but certainly one of them is not going to surprise anyone. I hate to kind of reiterate what we hear time and time again, but the development of data sets is a non-trivial task. If you think about what are the most time-consuming things that we do as an organization across all the partners, it is development of a data set, structuring a challenge, and then on the third piece is really certainly administering the challenge and then evaluating the results. And so you kind of have these sort of four big levels of effort that occur, which really from the idea of a challenge to its final evaluation blog, that's for us, we've really discovered that's a little over a year. And so for us, one of the foundational piece for that is often, can we build a data set that is not just interesting, but it really tackles a specific thing we're looking for, whether it's geographic diversity, seasonality, or just a data set someone hasn't seen, like the way we had the multimodal data set with Maxar imagery and the SAR collect from Capella Space. So for us, one of the biggest challenges is still going out, finding those data sets, making sure they're licensed the right way, and then going through the appropriate QA to QC to make sure that they're of the highest standard possible. So that's certainly a challenge number one. And I know anyone who's worked in this domain, getting access to high quality labeled data that's benchmarked, everyone has that problem. And so for us, it's still a challenge.
How do you do? You mentioned a bunch of your labeled data sets, the thousands that you have individuals manually edit. How do you outsource that work, or do you do it all in house? Between the small amount of folks that you got working at SpaceNet.
Yeah, it's a great question. To date, we have outsourced that work, and then we have done our own internal QA QC before we post those data up into AWS, and then certainly before they're structured for a challenge. The one exclusion to this was with SpaceNet 6. There was sort of already a robust building footprint data set that was available for this case Rotterdam, and we were able to leverage that. And by going through our own QA QC process, I think that was certainly an outlier, though. And most of the time, it's very hard to build data sets, and sometimes even if there are some data that are already available, or labels, that is, you still they may be inconsistent. The quality may be inconsistent. They may be inconsistent coverage or quality. And so we still want to make sure we launch a campaign for that. And I think just given the volume, right, think about what all of us want out of any type of geospatial data set. We don't just want a couple of buildings for a foundational mapping application. We need a lot. And so I think in the near term, that's something we'll continue to outsource and then do the final QA QC in-house.
For what you're doing for data right now, do you plan on sticking with satellite imagery based data, or do you plan to move into maybe aerial or full motion video as well?
Yeah, it's a great question, and
or a mixture of the two. Somehow tying commercial or imagery into detections for full motion video, or tipping and queuing off of that somehow from machine learning.
Yeah, you're really getting to one of the most actively discussed thing across all the partners, in the sense that Maxar's data has been pivotal to build all of our foundational work. And I think hopefully SpaceNet 6 I think serves as a model for where we want to go in the near term, in terms of having a multimodal data set where we have still that very high quality EO that is essential for building those models, but then you can start exploring how it applies to, in this case, SAR collect from Capella. I think one of the other things we're looking for is what are other modalities that could complement existing data sets we're already putting out. I mean, if you think about it, very rarely does one type of data set or one type of collect solve the problem that you're trying to answer, regardless of whatever the problem is. And so I think now that we've seen model performance really increase in a way that's exciting, as well as some of the software ecosystem, we're primarily a Pythonic group, but mature as well, you're starting to see these tools and complementary data sets to say, all right, I think we're ready to add perhaps some other types of modalities. I think this would go back to the previous question as well. What are some of the other technical challenges? The big question for us is always, another one is, what is the right amount of pushing, for each challenge? Because that helps inform what type of data set you want to take on, right? One thing that we've thought about a couple different challenges, but one is that came out of some of the results from SpaceNet 4, which was the Off Nadir challenge, which was a really cool Worldview 2 collect of of 27 images over Atlanta in about 4.5 minutes, from 7 degrees nadir to 54, was getting deeper into a time series component. Obviously, that's a short burst of time. Thinking about, could we do something longer? I think how to unpack that from both a analysis perspective as well as an evaluation metric perspective. All of those things I think are interesting to start exploring, and that's just one thing that we've thought about.
Great. So I'm going to transition to this, because we talked a lot about data, outsourcing some of the work you've done for machine learning and labeling. And this question makes sense coming from the audience as well. What is the process to becoming a SpaceNet partner, especially as you had a number of them sign in with you the last couple of months? And what does it mean to be a partner with the organization?
Yeah, that's a great question. So each year, all the partnership agreements are signed, and essentially right now we have 2 or really 3 tiers of partnerships. So we have a gold tier, a platinum tier, and then we have an academic or nonprofit tier. And groups can contribute, but either financially or as well with a mix of in-kind contributions. And so the max tier, the platinum tier, can contribute up to $100,000 and or an in-kind contribution of equal value. And the goal is that each one of those partners then helps us structure challenges, and then help us make the final decision on which challenges to pursue, what the structure should be, and what the timeline should be for that. And I would say that's one of the biggest real benefits of being a partner, is not just observing kind of the data sets that we're putting out or some of the challenges that we want to pursue, but adding their voice to the conversation about what the focus or foci should really be. And I would say, as we've added new partners, one of the things that's personally exciting for me as somebody who's been with this effort since the beginning, is that as we've had more participants, just the amount of discussion and dialogue, in some cases debate, has really grown. And I would say, as a result of that, the quality of the challenges and all the things that come from it, down to the post-challenge evaluation, has gotten better because of that discussion.
Great answer for those who are interested in becoming a partner or understanding the partnership relationships that you are forming. So one of the things that I'm curious about, this is coming from me actually, in the audience, is the so when you're going through this process, recording best practices, are you discovering that maybe going down the thought process of, is there sensors that we do not have in place, or sensor best practices that you would say, hey, we just don't have this capability, we don't have enough data of this sensor type, or we need to develop a new sensor because we're finding that our current sensor swath that's out there with the current collections and constellations out there just doesn't exist? Do you kind of get that feeling right now, or finding some of those I'm kind of curious. We have a lot of things going up in the air, but yet there's always new emerging sensors coming to the mix. But I'm wondering, as you're going through these hard use cases, if you're finding like, you know what, no one's making this, we need this into the community. Do you have kind of any thoughts behind that?
Yeah, I would say one of the most interesting things that we've learned, particularly I think through the data science challenges, is getting a sense of what end users are really looking for, or perhaps what's the lowest hanging fruit for people to use. And I would say, certainly with the Maxar data that we've been putting out, in a lot of cases we've been putting out all 8 bands of the MSI data from mainly WorldView 3, and we found that a lot of participants really just use the RGB data because that is, from a data science perspective, as we construct the challenges, sufficient in many cases for building a high-performing model. I think one of the things that I'm continuously surprised about is there are still there's still a lot of research to be done on how to leverage some of those other bands. Maybe not perhaps as much for some of the applications that we're structuring in our challenges, but for other types of data science projects. I think that same sort of exploration in terms of how to untap value in other data types is extensible as well to SAR, right? So if you think about it, the Capella collect that we had was a qual pol collect, and those data certainly offer a lot of information. Some of that work has obviously been rigorously researched in the SAR community. But I think we're really just in the challenge. We're really just scratching the surface, I think, of where the value could be, and so for that data type as well, in terms of how those data are fed into a model and how it could alter performance. So I think the big thing for us has really been continuously trying to figure out how to maybe push the ball forward on the data we already have and how we could leverage it. And I think from that, those insights will help inform what we're looking for from either future systems that are still being thought about, or it will certainly give us a better idea about where to plug in some of the new emerging assets as well.
And the reason I asked that, it just had me thinking some of the past sessions we've had with the Geospatial Frontier Conference, specifically most recently Monday with Chris Tucker presenting on his the data behind his book, A Planet of 3 Billion. Mm-hmm. I thought that was really fascinating. How he was bringing up how he's doing all this research behind data sets, and just the fact that certain areas of the world just aren't covered from a data perspective, especially when we look at areas of the ocean, monitoring garbage of the ocean or just general state of the ocean, that type of thing. The sensors just aren't there. Obviously the sensors are redirected to focusing on ship traffic with AIS or imagery tasking from AIS to look at maybe specific ships traveling, but not the ocean in general. Or you're looking at specific types of facilities out there that just aren't being monitored because the research hasn't been done to figure out what signatures and the different sensor types are out there. Once again, this is getting more into the ecology and environmental stuff, but I think there's a lot of overlap when when we're able to detect those types of things. I think it crosses over into definitely under industries, especially in defense as well. So
yeah, and this comes up. Think about how one may use or could use some of our models, particularly the roads piece. That may be a good starting point for thinking about how you could look for road networks in a disaster response scenario. I fully understand it's still early days with some of the work, but in that scenario, particularly for disaster response, you're going to maybe want to collect at a different time of day than what you want. There may be cloud coverage, which is certainly a compelling case for SAR. There may be a lot of perturbations in the image, so you may want some other type of either non-image data set or on the ground collect to verify some of the text. So yeah, certainly. I think once you break out of sort of at least from our perspective, the challenge structure, there's still a lot, I think, to be done in terms of other data sets that can complement or perhaps fill in some of the gaps depending on what type of application you're looking at. So, certainly as Chris is highlighting well, if you're looking at, like in a maritime scenario, those data start getting pretty sparse pretty fast. And in other scenarios, it's not very different.
So I'm going to leave this as my last question. Looks like we've kind of running out of folks coming in and giving us input. But to build off the theme of your whole presentation at the beginning and diving into the SpaceNet organization, how does the organization plan on growing or scaling doing multiple things at once? For example, you continuously do the SpaceNet 6 challenge, or sorry, SpaceNet challenges. Now, what if you plan twice a year now, if you're doing it in the fall, but are you going to work on other projects simultaneously and grow that effort out to increase maybe the size of the team and work with more companies at the same time? How do you plan on growing it and scaling it, and perhaps even working with new industries as you're bringing on best practices for what you're doing? down. It doesn't have to be an answer for this year, but perhaps maybe a roadmap to understand what you all plan to do.
Yeah, it's a great question. It's one that we've been discussing for some time. I think it kind of goes into sort of two categories. Certainly, if you think about those four pillars, one potential new pillar is not yet, but could be, is training. We held our first training event at Phosphor-G 2019, which was in Bucharest last year, on leveraging some of the algorithms we've put out through the challenges and the data set. And the feedback we got from that was really good. We had another training session, us with AWS and Intel AI at the AWS Public Sector Summit. Once again, the feedback was really strong from people who, all sorts of experience, people who are very experienced, people who are just getting spun up. So I think that is a offering that we should be thinking more about. As you have an increase in interest, you want to make sure that those interested stay interested and can start contributing back. And if they're looking for help or some Get Start guides or just wanting questions answered, I think that's something we want to think more about. On the maybe the more strategic side is, as we think about other data sets, particularly if you get into non-image data sets, we can also, or perhaps a really novel type of space-based collect for imagery. By its very nature of doing that, we sort of expand potential interested partners and end users who may already use that type of information. So I think for us, as we think about 7 and then after that 8, that's been one of the big driving forces is not just what are some ideas we have as a collective, but where do we see sort of demand or interest coming in now that our visibility is a little bit greater. So certainly trying to think ahead in terms of what challenges would be interesting to to broadening out engagement even more.
Interesting. And I said that was the last question, but I do have one more. You made me think about that a little bit. Does that involve potentially trying to invite bigger companies and traditional companies, so let's say commercial outside of normal defense or government related, or say outside the normal geospatial industry? What I'm thinking about is your Apples and Googles out there that have dived into machine learning quite a bit, Microsoft, that matter, and helping them leverage their technologies, or say inviting them to approach a challenge from our community's perspective with their technology, because they take a unique approach to things. And I'll even expand that to some of the even gaming community. Some of those companies have some unique approaches to how they've done graphic designs or employ intelligent behaviors within their systems.
Yeah, absolutely. I think there could be a lot of great opportunities for overlap with those groups. And so really interested to see kind of what comes out of some of the conversations ahead. And if any of those groups have specific ideas that they want to leverage on top of some of the current foundational mapping work, we would certainly be interested.
That makes sense. Ryan, I want to thank you for coming back on with us, and especially as part of the Geospatial Frontier Virtual Technology Fair. It's been great. Hosted by Project Geospatial, and once again, partnered with the American Geographical Society. It's always a pleasure talking about what SpaceNet is doing and what the updates of current challenges are as they're relevant to the geospatial community and progressing technology as a whole. Just general awareness of how things are progressing and all the sensors that you're involved with, because I think it helps expose different use cases out there that people are just unaware of. How can this stuff be used outside of, just understanding radar data, understanding that there's more out there than the just RGBEO stuff, right? Yeah. So, and I can't wait to see how that expands down the future. So thank you very much for joining us.
Adam, really appreciate the time, as always, and keep up the great work. Thanks, everyone.
Well, this is Adam Simmons with Project Geospatial with Ryan Lewis, signing off.